For numbers 1 and 2, you guys, how many rationals, hint, how many fractions do you see?
I see fraction.
One.
Just one. For each problem, there's just one fraction, right? Boom. Okay, so all we need to do is simplify this guy, meaning factor if possible, and then cancel out. So let's look at our numerator. Top guy. Can he be factored?
No.
Yeah.
Oh,
Yeah.
Yeah.
He
Can be fun.
He can be factored because we see that squared. We see 3 terms that we're probably going to have to play the number game with. So let's go ahead and play the number game. What 2 numbers multiply to negative 30, but then are going to add to negative 1? Multiply to a negative 30, add to negative 1. Think of the numbers that would multiply to 30. Which ones could possibly give you a 1 in there? Lily?
3 and 10.
That could give us like a 13 or a 7 if we combined them somehow. Which ones could give us a 1 if we combined them, Donovan?
10 and 30.
No, that wouldn't multiply to 30.
5.
6 and 5.
Oh, nice, you guys. You guys are so good. Okay. To get a negative 1, I want my 6 to be negative, right? So that factors to x minus 6. X plus 5, negative 6 times positive 5, that's where I get my negative 30. Negative 6 plus 5, or think 5 minus 6, gives me my negative 1.
Oh, no.
Great job.
No, it's an N.
Whoops. I know. I don't know why we love x so much in math. Is it actually an n?
Better.
Trying to find the map is X.
Trying to find the x's. Okay. So, the bottom. Here's where this might answer your question. Can we factor the bottom? Do you see a squared in there? Do they share anything?
No.
No. So the bottom is factored.
Factored. Oh.
Now simplify. What can cancel? What's the same on top and bottom?
N minus 6.
N minus 6 and n minus 6. Doop, doop. So the only thing we're left with here on top is n plus 5. What's left on bottom?
1.
Jenny, if you're going to distract my students. Lily, no talking to my aides. What's left on bottom?
1. No.
1. Do we have to put the 1 on bottom?
No.
No. So, simplified, n plus 5. Boom. Got it. Okay, number 2. Again, how many fractions, how many rationals do we see?
1.
Just 1. So we're not multiplying, dividing, adding, subtracting. We're just reducing, simplifying. So look at our numerator. Can we factor this guy? Do you see a squared in there somewhere?
Yes.
Yes. Okay, this is the special guy. Maybe put a star by him. Okay, think what multiplies to negative 9 and adds to 0 because that middle term disappeared. We practiced this twice on our starter. Think what multiplies to 9. Hint, what's the square root of 9?
9.
Yes,
It's
it's
9.
It's 3. So, in order to cancel each other out, 1 has to be a positive 3. 1 has to be a negative 3. That's where I got my negative 9 from.
Bless you.
And my denominator, can I factor x plus 3? Do you see a squared in there? Do they share anything?
Yes.
Nope.
No.
So denominator is factored.
You can cancel
That's
x
one.
plus 3.
Cancel x plus 3. Boom, boom. Only thing we're left with,
Plus 3.
x minus 3 on top.
True.
Anything left on bottom?
No.
Nah, just the invisible one, which we don't have to write. So x minus 3, all we're left with. Nice, love it, love it. Okay. Numbers 3 through 6. So for example, let's look at 3, because it's just telling us to simplify. How many fractions do you see? 2. What's the operation in between them? Multiplication. So we are simplifying by multiplication. Here's the great thing about multiplying fractions. It just turns into one giant fraction, which means we can cancel things out. But in order to cancel, we got to
Simplify.
by, starts with an F,
Fraction.
Factoring. Okay, so let's factor this numerator first. This piece right here. Ooh. Think 10 and 30. Is there a number I can divide both 10 and 30 by?
3.
No, I can't divide 10 by 3.
9 and 10? No.
I was thinking like 10.
10.
Can we divide 30 by 10?
Yes.
Yes. Which means we can divide both 10 by 10. Okay, we can take out a 10. And we can divide 30 by 10. Okay. Now, this guy has 2 M's. This guy has 1 M. How many M's can I take? Beautiful.
It's an M.
Okay, let's figure out what's left. 10 divided by 10? 1.
1.
2 M's, take away 1 M. Just leaves me with
1.
1 M. 30 divided by 10?
That's gonna be
3.
3. I had 1 M, but I took it out. So all we're left with is M plus 3 there. Okay. What about this times by 1? Do I have to put the times by 1 on top?
We don't know.
Does multiplying by 1 change anything?
No.
Nah, so you don't have to put that times by 1. Okay, so we're just gonna see you later.
Doesn't that kind of act like 0?
It's invisible, right? Multiplying by 1 doesn't change it, so we don't like to write it. Okay, 6. Can I factor 6?
No.
No, so we're just gonna leave them 6. Okay, then it's being multiplied, so separate these two guys by 10m, my other denominator. Okay, boom, we made it one big fraction, so now what pieces can cancel out?
10.
10m and 10m, which means I'm just left with m plus 3 for my numerator and 6 for my denominator. Boom. We love it. Okay, let's look at number 4. What's the operation? Yes, Isaac. You may. What's the operation? What's happening in between these two fractions?
Multiplication.
Multiplication, which means at the end we can just make it one big fraction, cancel things out. So all we have to decide is, can it be factored? Can I factor 1?
No.
No. Can I factor my other numerator?
Yeah.
Yes. Ooh, think 4 and 32.
That's going to be 8. No. 4. It's gonna be.
It's gonna be 4,
I did
right?
it again. I did. the
You're
other
thinking a
side.
step ahead. Okay, so on top, my numerator, I can divide a 4 out of those guys. So 4 can come out. Can I take a K out?
No.
Okay.
No, because they both don't have it. So I'm left with 1K. 4 divided by 4 is just 1, so 1K.
Okay.
What's negative 32 divided by 4? Negative 32 divided by the 4 we took out?
Was it full?
Quick.
I can't. Oh, that's 8.
Negative 8. Thanks,
I
Eli.
said that earlier tonight.
You did.
I
Okay.
said it again.
So now, you guys, we have our other denominator, which is just 6K. Can't really factor him, so he's just going to stay 6K.
6K.
And then 4. Okay, everything's factored. So now what can cancel? What's the same on top and bottom? Donovan?
Full.
4 and 4. So I'm left with K minus 8 on top over 6K on bottom. Okay, awesome. So with multiplication, again, it's just factor, cancel, cancel. Okay? Now what are we doing? Now what's my operation in between?
Divide.
Division. Okay, so let's write this on our paper. This little saying, keep, change, flip.
Okay.
Nice. Keep, change, flip.
Thanks, yeah.
Sure. However you want to remember that.
KFC.
Alrighty. Okay, so now that we're dividing, do you guys want to factor first or flip it first?
Flip it.
Let's factor. I made the executive call. Okay, let's go ahead and factor our first numerator. Okay, we need to play the number game with this first numerator. What's going to multiply to negative 18?
9.
Add to 3.
9.
No, 9 and 2 wouldn't give me a 3.
Negative 8?
No, I can't divide 18 by 8. What about 6 and 3?
Yeah.
6 and 3, let's try it. We got M. Let's see, to get a positive 6, or a positive 3, excuse me, I need my 6 to be positive, 3 to be negative. 6 times negative 3, negative 18. 6 minus 3, positive 3. Okay. Now let's go ahead and factor the denominator, because remember, this fraction stays the same. We keep it the same. Ooh, think 10 and 60. What can I divide both of those guys by?
8?
10.
10. Okay, I can divide both of those guys by 10. Which means I'm left with 10 divided by 10 is just 1, so 1m. 6 divided by 10 is what? Whoops, I just said it. 60 divided by 10 is what?
Negative 10?
6.
Positive 6. Okay, so we kept the first fraction. All we did was factor where we could. Now we change. It changes from division to multiplication.
Oh, yeah, that's right.
Oh, ooh, and look at these guys. Can we factor either of these guys?
No.
Yeah.
No. So let's just flip them. Keep, change, flip. M plus 8 is now on top. M minus 3 is now on bottom. Now that it's multiplication, just ask yourself what can cancel? What pieces can cancel?
M minus 3.
Mm-hmm, mm-hmm,
And M plus 6.
mm-hmm, mm-hmm.
And then we're left with.
On top, M
we're
plus
left
8.
with- We're left with plus 8 on top and 10 on the bottom.
Got it. You got it.
Man, I need.
Okay, keep, change, flip for division. So let's do that again for number 6. Ooh, let's look at our first numerator. First guy, P plus 6. Can I factor P plus 6?
No.
No, right? They have nothing in common. There's no squared that we see. So this just stays P plus 6.
P plus 6.
What about 4? Can I factor 4? Nah, stays 4. Okay, that was easy. Keep the first guy. Didn't have to factor anything. Change from division to multiplication. Now, let's go ahead and factor these guys. So let's go ahead and look at the top, even though he's going to move to the bottom. Let's factor him first. What's going to multiply to 12, but add to 8? Two numbers that multiply to 12, but add to 8.
6 and 2.
Beautiful. So now that they move to the bottom, this becomes P plus 6, P plus 2. That numerator then became the denominator because we flipped them. Okay. Last thing we need to factor, 8P plus 16. They do have something in common. What can I divide both 8 and 16 by?
8 and 3?
What is it?
8.
8. We can divide them both by 8, so we can take an 8 out. I'm left with P plus 16 divided by 8 is 2. Nice. So we kept the first guy, didn't have to factor anything there. Changed from division to multiplication. And factored and flipped. What can cancel?
P and 2?
P plus 2 over P plus 2. Yes. Anything else?
Plus 6.
P plus 6 and P plus 6. Ooh, I like this guy. We're left with 8 over 4. Now, if you were to put that in your computer, it would mark you wrong. Why? What's 8 divided by 4?
That's 2. 2.
Because it can be reduced even more.
Just 2.
Final answer is 2.
2. I'm just gonna.
So that
write 2.
whole thing simplified to 2.
I just wrote a big 2.
Nice. I like it. Okay, show me a fist of 5 on multiplication and division. Factor, cancel. Factor, cancel. With division, all you gotta do is just flip the other guy. How you feeling? Nice.
Feeling.
Okay. Now, for 7 through 10. Ooh, What are we doing now? What's the operation in between these guys?
Subtract.
Subtracting, and then we're going to add a couple. Okay, so let's write the rule. Actually, we don't need to write the rule. Let's just underline it right there. Nice. So the denominators must be the same in order to add and subtract them. Like I said, your notes today are actually harder than your review and your test. That's always a good thing. Okay, so let's look at number 7. Are my denominators the same?
No.
No.
No. One's a 2, one's a 3 times x plus 3. Yeah, no. Okay, so just like on our starter, easy fix. Let's take this denominator, multiply it over there. So 2 is going to multiply to that guy. Then we're going to take this denominator, and it's okay that it's kind of a bigger piece. We're going to do the same thing, just multiply it to this guy. 3x plus 3 multiplies to 5. And that little move right there is what makes your denominators the same. Just take them, multiply them across. Okay, so let's see what we get. Let's do this first piece. Okay, so I'm going to take 5 times this guy. Well, you guys, what is 5 times 3? 15. Okay, now we needed to do some distributing. What's 15 times x? That x right there, 15x. What's 15 times 3?
Oh my goodness. Let's search it up.
15.
Use a calculator. 15 times 3.
45.
45. Okay, so there we go. There's our first numerator when we multiplied it out. Okay. Now, we are subtracting here. So I'm actually going to make this a negative 2. So now we have negative 2 times x minus 6. Let's go ahead and distribute that out. What's negative 2 times x?
2x.
Negative 2x. What's negative 2 times negative 6?
Negative 12.
Not negative,
Positive.
positive 12. Okay, and there is our numerator. All we got to do now is combine like terms. So where are my like terms that I can combine here? Okay.
2x and 15x?
Yes, sir. 15x. Subtract 2x is going to give me how many x's?
It's gonna give me
13.
13. So we get 13x. Any other like terms I can combine?
No.
12 and 45.
45 plus 12 is going to give us what?
it's gonna give us 57.
Mm-hmm.
57.
Boom. There's our simplified numerator. Now just put the denominator on bottom. Okay, so let's go back and look at our denominator. Let's just go ahead and combine these guys. 2 times 3. What's that going to turn into on bottom?
6.
6. And then x plus 3. So we just wanted to turn that 2 into the 3, multiply them together. Nice, pretty 6. Boom. Simplified by subtracting. I want to make one note. This little move right here. When you're subtracting, what do our signs do?
Change.
Mm-hmm. Boom. That's that move right there. Signs changed because we were subtracting. 8, 9, and 10 we're all adding, so we won't have to worry about that rule. But make sure you remember that with subtraction, those signs after it change. Okay? Alrighty. Let's look at number 8. We're adding, which means our denominators still have to be the same. Are they the same? No, they look really similar, but n minus 2 is not the same as n plus 2. So we got to fix it. Let's take n minus 2, multiply it to that guy. Take n plus 2, multiply it to that guy. And that little move right there is what makes our denominators the same. Okay, so my first little piece is going to be 5n times n plus 2. Let's go ahead and distribute that out, see what we get. 5n times n. 5n squared. 5n times 2,
10.
positive 10n. Boom. There's our first little piece. Now let's do our second little piece. We are adding, so no worries about signs changing here. 2 times n minus 2. Okay, well, what's 2 times n?
4. Negative 4.
2 times n,
2n.
2n. 2 times negative 2,
Negative 4.
negative 4. Boom. Multiplied it out. There's our numerator. All you got to do now is combine like terms. Where are my like terms I can combine here, though?
10n and 2n.
Nice. My terms with only the 1n's. So what is 10n plus 2n going to turn into?
12n squared. 12n.
12n. Beautiful. So we got 12n right there. 5n squared we couldn't combine with anything. Negative 4 we couldn't combine with anything. There's our numerator. Let's put it over our denominator with both pieces, n minus 2 and n plus 2.
E.
E. E. Let's do, I'm feeling nice here. We're going to go ahead and skip number 10. Let's finish up with number 9.
We're not done with this number 9 right here.
Are my denominators the same?
No.
Nope. So we got to fix that. We got to make them the same. Okay, well, our move that makes them the same, take that denominator, multiply it across. Take that denominator, multiply it across. Boom. There's our little move that fixes it. Okay, so now we have this first little part, 4 times n minus 2. Okay, let's go ahead and distribute that out. You guys know how to do that. 4 times n?
4n.
4n. 4 times negative 2?
Negative 8. 8.
Beautiful. Okay, next little piece we're adding, so no worries about signs changing here. Plus 6 times n minus 1. Well, what's 6 times n?
6n.
6n. 6 times negative 1?
6.
Negative 6. Alrighty.
4n go together, 6n go together, and 8. Negative 8 and negative 6.
Love it. Combine like terms. What is 4n plus 6n going to give me? How many n's? 10n. And what about negative 8 minus 6 more? We're at negative 8 and we're getting 6 more negative.
14.
Nice. Boom. There's our numerator. Now just put both pieces on your denominator, n minus 1 and n minus 2. Whoops. There you go. Might want to be able to see it. And you're done.